Hello everyone, so this is a lesson on forming expressions in the context of area and perimeter problems, and we're going to be using what we've learnt when multiplying variables and multiplying terms, and also what we learnt when we did collecting like terms. So just before we start this off, just a quick reminder that when we find the area of a shape, that means we are finding how much space is contained within that shape. And hopefully this illustration can show you that within this rectangle there are 15 of these squares held within there, held within the edges of the shape. So that is your area. And we know that for different shapes there's different equations we can use to find the area. For rectangles, we can multiply the base and the height together. We can do the same for parallelograms, and for squares as well. We just need to multiply the two side lengths. For triangles and trapeziums and other shapes, we need to use different formulae. And then perimeter is the distance around the edge of a shape. So the perimeter is just how long the line around a shape actually is. Okay, so that's just to remind you. So we'll first look at some rectangles, and this is example 1, which you should copy down. So I've got a rectangle here with side length 3p and side length 5, and all measurements in this lesson are in centimetres, and I haven't written centimetres on any of them. And our first question is to form an expression for the area of the shape, and then we will form an expression for the perimeter. That's supposed to say perimeter. So for the area, we know that the area of a rectangle, and that's what this little subscript means, area of the rectangle is base times height. So you might be using length times width, but I say base times height. So I'm going to substitute the base 3p, the height 5, and that means my answer becomes 3p multiplied by 5 is 15p centimetres squared. That's my final answer with my units. For the perimeter of the rectangle, so that's what my little subscript here means, the perimeter of this rectangle is going to be the side lengths added up, right? So I've added 3p and 5. Now, that's not correct on its own, is it? Because we need to add all of the sides. Remember the illustration from the previous slide, it's the length of the line all the way around the shape. So we need another 3p and another 5. This is where we're going to be using collecting like terms. We can see we've got like terms here. So we can collect those up to 6p plus 10 centimetres. And that's the final answer for the perimeter of this shape. Here's example 2. So here's another rectangle. This time I've got side lengths 3p and 5q. For the area, I'm going to use the same equation, base times height. That means I'm going to be doing 3p multiplied by 5q. And then I need to remember my rules when I'm multiplying terms here, don't I? I take out my multiplication symbol. I make sure my letters are in alphabetical order. So I'm going to have 15pq centimetres squared as my final answer. For the perimeter, we are going to add all of our side lengths together, but we do need to make sure that we collect like terms, so we can collect our 3p and our plus 3p and our plus 5q and plus 5q to get 6p plus 10q centimetres, and that's the final answer. Notice that the units for area and perimeter are different. Perimeter is just a single line, and we measure lines with rulers in centimetres. Whereas area, we're not measuring a line, we're measuring space. We're measuring how much 2D space is within there. So we're measuring that in square centimetres. And then our third rectangular example, is this one where I have side lengths 3p and 5p. So we're going to use the same formula, base times height. We're going to substitute our base and height, 3p multiplied by 5p. And again, we're going to remember our rules. We take out the multiplication symbols, we make sure our letters are in alphabetical order, although we've got two p's here. So they're not going to be written as pp, are they? we're going to use our indices to help us write that nice and short, in the shortest way possible, as 15p squared centimetres squared. That's your final answer for the area of this shape. For our perimeter, we're going to add all of our sides together and then make sure we collect like terms. But all of these terms are like terms, aren't they? Because they have the same variable and the same power, 1. So that means we get 16p centimetres for the perimeter. Here are 6 questions for you to have a go at, so please pause the video and you're going to be forming an expression for the area and the perimeter of each shape. Off you go. Okay, I'm going to go through the answers to these now. So for question 1, the area turns out to be 76a and our perimeter is 8a plus 38. Question 2, for the area, we need to multiply 4a and 6b to give us 24ab. Remember, the letters must be in alphabetical order. And our perimeter, we're going to be doing 4a plus 6b plus 4a plus 6b gives us 8a plus 12b. For question 3, our area is going to be 4a squared multiplied by 2.5b. So we need to remember, we take out our multiplication symbols, we need to make sure we do 4 times 2.5 correctly, and we need to make sure our letters are in alphabetical order. So our area becomes 10a squared b. For our perimeter, we're going to be adding up our 4 side lengths and collecting like terms. So we get 8a squared plus 5b centimetres. Question 4, to get our area, we're going to be doing 4a squared multiplied by 2.5ab. So we need to make sure we do 4 times 2.5 correctly. And then a squared times by ab, well, that means I'm going to have a squared times by a. So that's going to affect this power, isn't it? So I end up here with 10a cubed b, because I have a squared here times by another a. So that means my power goes up by 1. And then b on the end. And then my perimeter, I just need to add up my sides and collect like terms. Now, 4a squared and 2.5ab will not be like terms because we need the same variable to the same power. And the variable and power here is a, and then the power is 2, and the variable here is ab. So these are not like terms, and we get 8a squared plus 5ab. For question 5, our area is going to be 125 FG times by 6GH. So we need to make sure we do 125 times by 6 correctly. Then we need to be having all these letters in alphabetical order. And also, because we have G multiplied by G, we're going to get a G squared term. So this becomes 750 FG squared H. The letters are in alphabetical order. The G and the G has become G squared. And then the H obviously is just on the end. And that is the expression for the area. And then for perimeter, we just need to add up our terms and collect like terms. So for perimeter, we get 250 FG plus 12 GH. These are not like terms because we don't have the same variable. And then question 6, we're going to be doing 12 ABC multiplied by 6.2 AB. So we need to be careful with our decimal multiplication, make sure we do that correctly. And then we've got A times by A, which will give an A squared term, and B times by B, which will give a B squared term. And then C is just multiplied by all of this. So we get 74.4 A squared, B squared, C. For the perimeter, we do 12 ABC plus 6.2 AB plus 12 ABC plus 6.2 AB. So we get 24 ABC plus 12.4 AB. Now we're going to look at some examples of triangles. So you're going to copy these examples into your book. So we're going to be forming an expression for the area of the triangle and then for the perimeter of the triangle. So for the area, the formula for the area of a triangle is base times height divided by 2. But I'm going to be using this equation, a half times base times height. These two are exactly the same thing. It's just that when I'm doing my algebra, I just prefer to use this one, but both of these will give you the same answers. So I need to make sure I choose my base and my height, and remember the base and the height have to be perpendicular to each other. Okay, so in this triangle I'm going to be using 5p and 3 because these are the two side lengths that are at a 90-degree angle. This side length over here is not at a 90-degree angle to any of the other edges, so it is not either the base or the height. So I'm going to be using 5p and 3. So I'm going to substitute those into this equation. 1/2 times 5p times 3. I'm going to leave the half till the end. So this becomes 1/2 times 15p. And then I'm going to multiply this by 1/2 and get 7.5p centimetres squared for my area. For my perimeter, I just need to add up the three sides. So 3 plus 5p plus 4p plus 6. And then I collect like terms, so I can see I've got 5p and 4 and positive 5p and positive 4p, which are like terms, and then 3 and plus 6 are like terms to get 9p plus 9 centimetres for the perimeter. Here's another triangle. I'm going to use my same equation, 1/2 times base times height, and I'm going to be using 5p and 3d as my base and my height here. So 1/2 times 5p times 3d. I'm going to leave the 1/2 till the end to do, so I get 1/2 times 15dp. Remember, my letters have to be in alphabetical order, and I remove the multiplication symbols, and then my final answer is 7.5 dp centimetres squared. For the perimeter, same as before, you're just going to add up all of your side lengths. So we're going to have 3d plus 5p plus 4p plus 6d, and collecting your like terms here. So we end up with 9p plus 9d centimetres for our perimeter. And one more triangle. This time our base and our height are going to be 5pq and 3p. So I'm going to substitute those into 1/2 times base times height to get 1/2 times 5pq times 3p. I'm going to leave the 1/2 till the end. So over here I get 15p squared q. So I've got p times p, which becomes p squared, and then I'm still multiplying by q here. Then multiplying by 1/2, we get 7.5p squared q centimetres squared for the area. For the perimeter, we're just going to add up our three side lengths and collect like terms, but you'll notice you don't have any like terms here. 3p is not like terms with 5pq, and that's not like terms with 6. They all have different variables, don't they? So our final answer is just 3p plus 5pq plus 6 centimetres. Okay, so here are some triangles for you to have a go at. You're going to pause the video now and have a go. Okay, so we're going to go through the answers to these. So for question 1, our area is going to be 1/2 times 4g times 5, and that gives us 10g. And then our perimeter is adding up our three sides, which is 10g plus 5 centimetres. For question 2, our area will be 1/2 times 4g times 5.5g, which, oh, I have a feeling I've done this one wrong. Yep, I should have a g squared here, right? Because I've got g times g, so 11g squared is the answer there. Then for my perimeter, I'm going to add up my three side lengths, and that gives me 15.5g centimetres for my perimeter. For question 3, I'm going to be doing 1/2 times base 3g times height 5t, which gives me 7.5 gt, and then my perimeter is my three sides added up, but we don't get any like terms here, so I couldn't simplify at all. I just had 3g plus 5t plus 6gt centimetres. Just to mention as well, you can have these terms in a different order and your answer would still be correct, because remember, when you have your different terms, you can put bubbles around your terms, if you remember one of our previous lessons, and you can switch the order around of the bubbles and it's identical. So if your answer says 5t plus 3g plus 6gt, that's identical to my answer. So don't worry about the order as long as the sign and the term are the same in each answer. For question 4, we're going to be, for the area, we're going to be 1/2 times 8t times 3gt, which is 12gt squared. I've had to make sure that my letters are in alphabetical order with the G first, and also that I've done t times t is t squared. Then the perimeter, we are adding up our 3 side lengths, and we do have some like terms because 6gt is like terms with 3gt, isn't it? So we can add those up to get 8t plus 9gt. Again, having that the other way around, 9gt plus 8t is identical to that. And question 5, we were practicing multiplying our decimals a little bit here. For our area, we had to do a half times 0.5a times 1.5b, which gives us 0.375ab. And then perimeter is the 3 sides added up, and we do have some like terms here with 0.5a and 2.25a. So our perimeter is 2.75a plus 1.5b centimetres. Now we're going to look at a couple of examples of shapes that look slightly different because we've just done rectangles and right-angled triangles. So here we've got a triangle that isn't a right-angled triangle. I've got my 3 side lengths shown and then also my perpendicular height here. So for the area, I'm going to use the same equation as the triangles we've done previously, a half times base times height. So I'm going to be doing a half, and then my base and my height, remember, have to be perpendicular to each other. So 6t and 4t are my base and my height here. So I'm going to be doing a half multiplied by 4t multiplied by 6t. I'm going to leave the half till the end, so I'm doing a half times 24t squared, and that would be 12t squared centimetres squared for my area. For perimeter, I'm adding up the outside edges, so I'm not going to be using the perpendicular height when I'm doing the perimeter, because that's, within the shape. The perimeter is the length around the edge of a shape. So I'm going to be doing 7t, 4t plus 7t plus 9t take away 3. And then I'm going to collect like terms to get 20t subtract 3 centimetres for my perimeter. Here's a trapezium. You might want to pause the video and go back through your book and remind yourself of the formula for the area of a trapezium. You might remember it straight away. If you can't do either of those things, then obviously I'm going to write it on here too. So for a trapezium's area, you learn this formula. We usually learn this formula first. A plus b over 2 times h. H is the perpendicular height, and then A and B are your parallel edges. So these two edges here, 60 take away 3 and 40 plus 3, they are parallel to each other. If I was to carry on this line here and carry on this line here, these lines would never meet. So they're the parallel edges. And our height over here, 5t, is perpendicular to those. It's at a 90-degree angle. So this formula is fine. I'm going to use a slightly different version. I'm going to use a half times a plus b times the height. These two things are absolutely identical to each other. So, substituting in what I have. So a and b are my parallel edges. 6t take away 3 and 4t plus 3. And then my height is 5t, but in some separate space I'm going to work out what this a plus b part is, okay? So I'm going to work out what a plus b is and I'm going to put it in here. So over here in some other space I'm going to do what a plus b is. So I'm doing 6t minus 3 plus 4t plus 3. And when I collect like terms here, my 6t and my 4t will become 10t, and my negative 3 and my positive 3 will actually cancel each other out. So a plus b is equal to 10t. So I'm going to put that back into my equation over here. So a half times 10t plus 5t. I'm going to leave the half to the end, and 10t multiplied by 5t is 50t squared, and then multiplying that by a half is 25t squared centimetres squared. And that is my expression for the area of this shape. For the perimeter, we just add up the outside side lengths. So adding all of these up, it's quite a long expression, but luckily we have lots of like terms that we can collect together, and we end up with 21t centimetres for the perimeter. So here are some non-right angle triangles and some trapezia for you to have a go at. So pause the video now and have a go at these 5 questions. Okay, so question 1 is an equilateral triangle. So to find its area, we're still going to do a half times base times height. You can see here that I've shown you the perpendicular height is 6 and the base would be 14y. So we're going to be doing a half times 14y times 6, which gives us 42y. And then for our perimeter, we just need to do 14y plus 14y plus 14y. Alternatively, you could do 14y multiplied by 3 to give you 42y. So this is a really interesting shape where the area expression and the perimeter expression are the same. That's quite an unusual result. Question 2 is a trapezium. So when we first do a plus b, we're going to be doing 2y plus 3y, which is 5y, and then we're going to be doing a half multiplied by that 5y multiplied by the height, and the height is 5. So our area expression becomes 12.5y centimetres squared. For perimeter, we just add up the 4 sides that we have, and that is 5y plus 11 centimetres. For question 3, another trapezium, we're going to be doing a plus b, a half times a plus b times the height. Now a plus b is 7y here. And then when we multiply that by the height, we need to do 7y multiplied by 1.5y. And we then need to multiply that by a half. So we end up doing some decimal multiplication here again. So we get 5.25y squared centimetres squared for our area expression. For our perimeter expression, we simply add up the 4 sides to get 10.5y centimetres. For our triangle over here, this is an isosceles triangle. We're still going to be doing a half times base times height, and our base and our height are 14y and 26y. So we need to do a half times 14y times 26y, which is 182y squared centimetres squared for the area. For the perimeter, we need to do 14y plus 220 plus 14y plus 220. So there are 3 sides that are added together, and that is 42y plus 440 centimetres. And lastly, we have an isosceles trapezium because it has 2 equal sides. Same formula though, half times a plus b multiplied by the height. So a plus b, 1.6y plus 11 and 2.7y take away 11 is going to give us, I think it is 4.3. Yeah, 4.3y. We then need to multiply that by the height, which is y, so 4.3y squared, and then multiply that by a half. So we get 2.15y squared centimetres squared for the area. For the perimeter, we are adding all the outside edges, which means the y here is not included, and that gives us 4.3y plus 12 centimetres. Now, lastly, we will look at some compound shapes. So we're going to look at 2 examples of compound shapes, which you should copy into your book. Now, compound shapes we're going to answer in the same way as if all of our side lengths were just numbers. We would split the shape into 2 rectangles. I'm going to call the 2 rectangles A and B. And then you would find the area of A, find the area of B, and add them up. Before I do that though, I'm going to find what these missing side lengths are, okay? Because then I'll be able to do my area and my perimeter. So, I'm going to do my numerical one first. So this side length here is 9 and this side length here is 4. So that means that this side length here must be 5. And then this side length here is 3t and this side length here is t. So over here we should have 2t. And now I've got all my side lengths labelled, I can do my areas. So AA stands for the area of rectangle A. So this small rectangle up here. And that's 2t multiplied by 4, which is 8t. Then the area of B, so A with subscript B means the area of shape B here. And that's going to be 3t multiplied by 5, which is going to be 15t. And then I need to add those up. So A total, so the area of the total shape, 8t plus 15t is 23t centimetres squared. For our perimeter, we need to add all of our side lengths up. So we get a long expression like this, and then we collect all of our like terms to get 6t plus 18 centimetres as our perimeter. Another example, I'm going to do the same thing. I'm going to split this into two rectangles, label them A and B, and then find my missing side lengths before I do any calculating. So over here, this missing side length, well, it goes across the full length of the shape. So it's going to be 2t plus 2t plus this 2t. So that's going to be 6t. Then my missing, I do have some other missing side lengths before I start doing the area, but this one here is going to be the same as this one here, so this is still t. And then this one here is going to be the same as this one here, which is 9, but I haven't labelled those. Now for the area of A, I need to do the base times the height because it's a rectangle, so 6t times by t, which is going to be 6t squared. And for the area of B, I'm going to be doing 2t multiplied by 9, which is 18t. And then the area of the total is those two things added up. But this time we can't collect like terms because these are not like terms, they have a different power, don't they? So that is our expression for the area, 6t squared plus 18t centimetres squared. For our perimeter, we need to make sure we add all of these side lengths, so 2t plus 9 plus t plus t, plus 2t plus t plus 6t plus t plus 2t plus 9, and we get 14t plus 18 centimetres as our perimeter. So here are 3 compound shapes for you to have a go at. Pause the video now and follow those steps. So breaking the shape into 2 rectangles, labelling the missing sides, finding the individual areas, and then adding those up. So off you go. Okay, so just to go through the answers, so I'm going to label the missing sides for you and then show you the expressions for area and perimeter. So the missing sides on this shape, this one is 32, so that's 45 take away 13, and then this side here is 4r, and then our area expression is 193r centimetres squared, and our perimeter expression is 10r plus 90 centimetres. For question 2, our missing side lengths are 9r here, because we have 11r take away 2r, and over here we're going to be doing 6r plus 5r, which is 11r. And then the area expression is 67r squared centimetres squared, and our perimeter expression is 44r centimetres. And for question 3, our missing side lengths are 3t down here, because we have 8t take away 5t, and over here we will have 3r, because that is 6r subtract 3r. Then our area expression becomes 33RT. You need to make sure that your letters are in alphabetical order here. And your perimeter expression is 12R plus 16T centimetres.